One day we may settle thousands of planets and trade between them, but what would a space freighter be like? Who would crew them, and what would they carry? A lot of times we look at the sheer immensity of interstellar empires and Kardashev-scale civilizations, where you might have billions of times our population and need billions of times more people in every type of job than we have nowadays. But we don't zoom in on the real logistics very often. And last year we had a pair of episodes on hive worlds and hungry aliens, and both spent some time talking about the realities of trying to feed huge megametropolises covering whole planets, or giant growing space empires. But we skipped a lot of the logistics as it was getting a bit into the weeds and off topic for either episode, and one big piece of that is moving everything around. So we produced a short companion episode on Nebula for both on space freighters, and I said in that episode that the topic probably needed more than a short bonus companion piece, its own episode at least if not series, and today we'll be taking an expanded look at the topic, particularly to discuss what sort of cargoes they carry and how much cargo they might carry, as well as how much crew they'd have and what their lives might be like. So if that sounds interesting, or if you'd like to see more episodes on the topic, make sure to hit the like and subscribe buttons, then rummage around your own cargo bays or fridge for a drink and a snack to enjoy while we take a look at space freighters, their cargoes, and crews. Space freighters or trade ships are a staple of science fiction. We don't get much serious scientific or economic analysis, and understandably so, as it's hard to do either without knowing way more details about the specific technologies, civilizations, and economies in play. Now, you do not need to have watched either of those other episodes, Hive Worlds or Hungry Aliens, to watch this one, but if you saw Hive Worlds, some points we made there was that food can actually be pretty compact, in terms of both mass and size, so that those enormous ships that are ubiquitous in science fiction could carry enough food for a whole planet, or from a dedicated farming planet, and that such dedicated agricultural planets could each probably feed hundreds of billions, if not more. Even without getting ultra compact, the amount of food one person needs for a year is on an order of a cubic meter or ton, and less if we focus on dehydrated foods or calorie-dense options like fats and oils. A cubic meter of olive oil, for instance, 1,000 liters, contains just over 8 million food calories, more than 10 times what a person needs for a year. So a ship on par with an aircraft carrier, oil supertanker, or big container ship might carry enough food for tens of millions of people to eat for a couple months. Alternatively, some massive kilometer-long ship of the kind popular in science fiction like Star Wars or Warhammer 40,000 could potentially be carrying enough food for 1 billion people to live for an entire year in its holds. They could also carry billions off, so planetary evacuations or aid missions really are believable. If your technology permits it, the big freezer or stasis bins that let you move fresh food to a planet can be crammed with refugees on their way out too. And having them on stasis removes the major problem with a refugee ship, which is keeping those folks safe, healthy, and out of the crew's hair for the journey. Of course, there's no guarantee a classic sci-fi stasis pod or bay would ever be a thing, limiting you to foods you could freeze for long times, or were otherwise very durable, and to other goods besides food that were durable. The question then becomes if it could ever be economically viable to ship something as bulky as food around, and that is a case that's even harder to make in an interstellar context in a no-FTL universe, one without warp drives where light speed is the limit. Since unless you've got some sort of awesome stasis devices, the idea of a fresh delivery a couple decades later would seem ridiculous, except maybe in the case of certain products we like to age, such as wine or cheese or whiskey. Even then, a ship might spend a decade or more delivering one load of cargo, during which time it has to pay its crew, if any, its investors, if any, the shipyard that made the ship, or the bank they borrowed the money from at interest, and the maintenance costs. All while some local ship running cargo around a solar system might be doing months or a year per trip, getting dozens more trips in and selling dozens more cargoes. The situation is even better for those on lunar or cislunar and orbital trips around the swarm of habitats and other space stations we would expect near settled planets, which might be trips of a few days or even the same day, allowing hundreds of pickups and deliveries a year, and 1,000 during the time an interstellar trip delivered just one cargo. Now, the interplanetary case is an easier one, as is shipping down from high orbit like moons or artificial space farm megastructures, though both are still tricky. However, I think we should acknowledge from the outset that folks talk pretty casually about bringing in whole atmospheres and oceans to planets like Mars, and for a little context, Earth's ocean mass is currently estimated at 1.35 times 10 to the 24th kilograms. We often imagine bringing in parallel figures to create robust topsoils too. That's over a billion tons. And as we noted in Hive Worlds, if you're aiming to conserve mass, then a person can be kept alive on something like 100 kilograms of food a year, and with plenty of room to spare. We assume in this context a lot is probably dehydrated, and that a lot of fast-growing or quick-rotting fruits and veggies, like lettuce, get done locally in hydroponic farms, down on the planet, or in orbitals coming down via space towers or elevators. We are not necessarily assuming the most diverse, pleasant, or even healthy diet here, though again, it's not that conservative a figure, and we're not talking classic sci-fi NutriPaste or food cubes, let alone Soylent Green or 40K style corpse starch. Anyway, if your oceans mass a billion tons and you can feed 10 people a year off 1 ton, then the same effort needed to bring in an ocean can bring in food for 10 billion people for a billion years, till that star burns out basically, or 10 trillion for 1,000,000 years, or a quadrillion people for 10,000 years, which is itself usually on the high end of the sort of timeline people imagine for terraforming a planet. And I suppose one way to bring those oceans and soil in would just be to not bother dehydrating the food in favor of just recycling that food, post-consumption, for water and topsoil. So any situation in which you're seriously contemplating moving literal mountains or mountain ranges worth of raw materials to planets strongly implies you could very economically ship bulk cargo of other types around, especially if you're using options like space towers and orbital rings for your ground-to-orbit and orbit-to-ground movement. And if you can do it for food, I think it becomes plausible for almost anything else. The next question becomes, how big a freighter are we talking about? Engineering-wise, bigger isn't always better, but it usually is for moving huge amounts of bulk from a big collection point to a big distribution hub. That's why we have supertankers and giant container ships, as those hubs, in this case it might be from some huge space farm or habitat or agri-world to another planet or to some very urbanized space station, asteroid or moon. Cost isn't necessarily as constraining as we would tend to think. A lot of us feel the pinch of recent inflation on food prices, but a lot of that cost is coming from processing, packaging, and local storage at a store or restaurant, as opposed to the farming cost or bulk cargo transport from them, and thus wouldn't necessarily translate onto moving it between worlds. Moreover, as much as that cost is high, close to $2,000 a year per person for groceries in the US, the per capita income is 40 times higher than that too. So a civilization can get away with that portion rising quite a bit for importation needs, especially if they are technologically advanced and have a vastly higher production per individual than what is needed for basic subsistence, which historically has been closer to half just for food, not a few percent like now. It might surprise folks, but the output of American farms is not even quite 1% of the US economy, and agriculture, food, and related industries are just over 5% together, and just over 10% of the jobs. That can be a tricky count with farmers at times, as many are small farms whose owners are not full-time and not principally employed in that. My wife and I would both count as that. We own a farm. It's where we live and where I make these episodes, and we do actually produce off it. We are not hobby farmers, but it's not either of our primary jobs in terms of time or revenue. That's a thing to keep in mind in the context of the future. A spaceship requires very little actual navigation and piloting on what are fairly long journeys. A lot of the work for the crew of a cargo ship is at the front and back end of that trip, and likely a lot would be done by personnel at those ports, not just the ship crew. But they would still be busy then, and this implies a lot of free time for other activities during the journey. Thus, it's possible a ship's crew are all moonlighting in other careers. That can change the economics of a situation. so convene a post-scarcity civilization with a lot of robots and cheap energy, and the latter is strongly implied by even having an interplanetary economy. Moonlighting might be unrelated, or it might be a perk of their job as some free cargo space they can use to buy and fill with luxury items they plan to sell at the next destination. Historically, letting your crew have some cargo space of their own that they could fill with goods bought with their own pay from the most recent leg of their journey was a fairly common perk, and something for them to do with that money besides blow it at all the local dockside taverns and brothels. In terms of an economy, that might be a planet, or it might be that planet and its orbitals, or a system-wide economy, or even a Dyson swarm. In that last case, I can comfortably say that inter-object shipping is totally economical, since it would take less fuel or energy in most cases to travel to neighbors than it does nowadays. Your typical Dyson swarm is less population dense than the most deserted desert or tundra on Earth, but it's got trillions if not quadrillions of space habitats separated by vacuum and with no gravity of note to spend fuel escaping from, so you only need enough fuel to get up to a comfortable speed and back down again. A freighter wanting to make the 100,000 kilometer trip to a neighboring cluster of O'Neill cylinders, unless it's carrying bananas or some other food known for having minimal shelf lives, probably can afford to spend a week on that journey. It's just coming down to whether or not the cost for more fuel to go faster is going to cancel out your other costs like more wages for the longer trip and more maintenance and debt service on that freighter. But that means for a week-long trip, its cruising speed would only need to be 165 meters per second or 370 miles per hour, the same speed as a lot of commercial planes, not spaceships. And unlike a plane, it only burns fuel to get to that speed, not maintain it. Even assuming it can't get a boost running down a launch ramp or launching out the side of a spinning habitat, which it probably can, and that it has to do that with modern rocket fuel, it still needs less fuel than cargo, which for context probably means even in modern terms less than $1 a kilogram shipped for fuel cost. That means there would be precious few things you couldn't ship around a Dyson swarm or the smaller orbital swarms around planets for economical rates, even with modern technology for the shipping. Of course, we could rebut that by noting that with very good 3D printing and automation, that it is possible nothing really will be economical to ship because it would always be cheaper to make locally, because they can do it for the same cost and need no shipping, except of course for raw materials. Those are pretty much always going to be durable and marginal, meaning huge ships with tiny crews. Even there though, some luxury market for those who just have an original or authentic good, not one locally printed, is likely to remain and make up at least some small part of what is on some bulk freighter, even if we're talking a room-sized locker full of luxury goods on a ship the size of a supertanker full of raw materials like iron or ice. But my hunch is specialization will still reign supreme and places will be known for importing and exporting certain products. But let's go with gross system product or GSP for now, and assume the more urbanized elements can comfortably afford at least 1% of their economy be spent on shipping food in. Specifically, that's the transport cost, or room for revenue and profit for our freighter. It's obviously an intentionally round figure, but not arbitrary. It's pretty close to what it costs nowadays, and loosely speaking, whatever farms sell for is roughly tripled or quadrupled by the time it gets into a home refrigerator, and a lot of that is shipping and handling. Now, we might assume a very productive and high-tech economy has a lot less of its economy made of food, and a much smaller portion of it as staple crops, much as it is a smaller fraction nowadays compared to the subsistence farming most of our ancestors did until relatively recently. Having far more production though probably just makes shipping more economical overall. Let me add in the quick note that for ease of discussion, we are using our modern economy as our touchpoint. We can imagine a civilization with no money, Star Trek style, and we have looked at that before in other episodes, but a lack of money doesn't mean a lack of an economy, and you still need to provide goods and services and move stuff around. Except in more extreme cases like we looked at in the Hermit-Schopflitter hypothesis of the Fermi paradox. By that same notion, almost anything could be automated, but we tend to assume at a certain point of intelligence, an artificial intelligence or robot just becomes a different type of person, as opposed to a machine, and thus is still a crew member. It probably will be compensated in some fashion too, just like a person will, even if the pay is in something other than traditional money, like social points or filling your 100 hours a year of mandatory public service required to get your various privileges and rations. From a practical perspective, this may not be identical to a modern economy, but seems to have enough points of overlap that it works for our discussion today. I also don't think you'd ever have truly uncrewed cargo ships. Too much valuable material, too little reason not to have at least some crew for handling weird eventualities like hijacking, piracy, or scams. You wouldn't trust to something not bright and versatile enough to get the title of person. The episodes this one is originally a companion piece to were pretty dystopian, thus assume a lot of humans working full-time jobs or worse, but a utopian one is not likely to be one where people don't work at all. Feeling useless and without purpose isn't really utopian, so you might as well have a crew. In any event, let's assume for the moment that your space freighter is only eking out a 1% profit after all other costs but salaries for the crew: fuel, maintenance, spare parts, bank loans, docking fees, investor shares. If only 1% is available to be paying your crew, and only 1% of the economy is for this bulk cargo, say food, this still means the money is there for about 1% of 1%, or 1 in 10,000 people, to be working in the shipping of food through space specifically. That would mean each crew member would need food for 10,000 people to offset themselves. That's on the very high end, I think, but it does mean some megaton freighter carrying enough food to feed 10 million people for a year could get away with doing just one delivery per year and having a crew of 1,000. Or 1,000 people living off the dividends of the ship, or whichever. We were treating food as a commodity currency in this case to keep it simple. And again, that's on the low side. I suspect even being able to allocate 1% of GSP to paying sailors would be plausible enough, maybe more. And I would say that rather than 10,000 to 1 though, that 100 to 1 is a lot more plausible for freighters in general, especially for less bulky items. And if we're assuming the ship has a maximum density of water, like what any sailing ship has nowadays, then some ship with a cargo capacity of say 5,000 tons might be something on an order of a ship 50 meters long and 10 meters wide and tall, or 164 feet long and 33 feet wide and tall, making 20 deliveries a year, 2-week journeys with a few days of turnaround at the port. And that might be a crew of 1 doing well, or a handful barely scraping by, if we're assuming bulk cargo at that 10,000 to 1 ratio, or it might be a crew of dozens doing very well for themselves, while the captain might be quite wealthy, even by the standards of a post-scarcity civilization. Just to follow up on our hive world example though, where we are a lot more dystopian and not post-scarcity, we could imagine a scaled-up version of that last ship, 5,000 meters long and 1,000 wide and tall, or 3 miles long, carrying more like 5 billion tons of cargo, loaded up from a collection point of big high-orbit space farms just over once a month, or 10 times a year, bringing in enough food to feed 500 billion people a year. And you might have hundreds of space towers where one or more of these ships is unloading at a given time. In a case like this, even your more dystopian sci-fi examples, where this ship might have 1 million borderline serfs or galley slaves on board that are mostly compensated with room and board, this would barely scratch the food supply on that ship or its space. You would need 10 million of them to use up even 1/1,000,000th of the food on the ship, which is probably way less than got damaged by loading and thus won't keep well for later unloading, so you might as well feed your crew with it. And even for that full 10 million, you might be using less than 1% of its space for living and sleeping quarters without even having to pack them in as tightly as we do on submarine crews nowadays. Anything less than 1,000,000 would feel like the ship was empty, given that it might have 1 billion square meters of decks. One can imagine entire communities on those ships that mostly were not terribly productive compared to robots, simply because the ship's more senior crew would rather feed people to work than buy robots too. Especially given that for those shipping food, they will always have some damage in the shipping they can use for feeding their crew, which makes them cheaper than robots, or maybe they get a kick out of having their own personal kingdom. Ships like this, you're the governor of a state or CEO of a megacorporation. Only you're a captain, so in more ways like an autarch or absolute monarch, and the captain's chair probably is more like a throne. Crunching those numbers though, it would mean that when they got into port, each person out of that 1,000,000 was responsible for getting 5,000 tons of cargo on and off the ship, or 500 tons if we had a full 10 million crew. That's not even including fuel or any other work besides loading and unloading, so we're not really talking about work gangs moving the stuff on their backs, unless the crew number in the hundreds of millions. but more like entire fleets of cargo trucks running constantly down the boarding ramp or an actual train track unloading the cargo bays. And a railroad running continuously as one long train might be moving 10 or 12 tons of cargo a second, non-stop cars moving down that track, and you would still need 1,000 of those tracks to load and unload that ship in a few days. This is the reason why I would tend to think this was the upper limit of freighter size and probably past it for how big a cargo ship might be. Because while it's cool to speak of or animate ships miles long, that packing and unpacking issue is not helped by scaling up, and becomes reminiscent of the bottleneck caused by the elevator conundrum that we talk about in our arcology and space tower episodes. It is still doable though, even if you have to have the crew physically carrying the cargo off themselves, or using forklifts, or fairly automated forklifts that mostly drive themselves. We might even be able to make much more high-tech and efficient versions of pallets and barrels. We always talk about how automated spaceships might be, and in theory anything can be automated, but at this scale it really is not hard to imagine that you would need a crew of 1 million just to oversee and maintain all the automation involved in loading and unloading that ship, even if most of the manpower and equipment was from the port itself. We really can't imagine a ship of any size being navigated by a small crew of 12, especially with enough machines and robots, but when we dig in we see a need for a lot more. Just as another example, we usually say a single custodian can clean 10,000 square feet or 1,000 square meters of floor in a single workday. Some ship like that with decks say 5 meters high, for 200 total decks, would have 1 billion square meters of deck, and even if that only got cleaned every 10 days, that's 100,000 custodians swabbing decks. You automate that obviously, but now maybe you only need 1,000 folks who each maintain and monitor 100 Roombas each. To wrap it up, and realizing that I could easily expand on this topic into multiple full-length episodes, not that there's anything new there, we can do that for almost all our topics on this show, there is the question of fuel and propellant. But this is actually rather trivial in a fusion economy, or even one with good power or beaming, because it's really just hydrogen, be it fuel or propellant, and so long as you can pull that out of a gas giant's gravity well relatively cheaply, which you can in a number of ways including relatively low-tech options, then it's all about the assumption that most ships can go at about the exhaust velocity of that propellant out of the ship. And even if that's only 10 kilometers a second, which is low for an ion drive, then you've got all the speeds you need for interplanetary shipping and even expedited cislunar transport. Definitely a topic I'd like to expand more on, even after nearly doubling the script between its original airing on Nebula last year as a companion piece and its release a year later here as an expanded piece. We didn't even get to look at non-food cargoes or shipping routes, or the impact of various different drive systems, or much of a dip into what life as crew or captain on these might be like. Though I think we've established that even a society that puts hard limits on AI and automation not too far beyond what we have nowadays could get away with economical bulk freighters, and without having crew who would envy the guys on submarines or 19th century dock workers. Indeed, it might be a rather lavish lifestyle by modern standards even for the lowliest and most junior crew. However, that's all the time we have for today. I think we've established that there's a pathway to a future in which the freighters we see in so much sci-fi are a reality. Again, if you enjoyed this content and want to see more on this topic or related ones, make sure to hit the like and subscribe buttons, and leave a comment on the episode. We were talking about spaceship crews today, and I want to say a quick thanks to the crew here on the SFIA ship for the years of helping editing scripts, making graphics, moderating forums and pages, and 100 other things that help keep SFIA sailing into the future and delivering episodes every week. That same is also true of our sponsors, especially Brilliant, who is our longest running sponsor on the show and has made it possible for us to make quality content for you every week for years now, and quality content is something they understand. As many of you get ready to sail off for the summer from school, I'd like to encourage you to think of learning as a constant process. Enjoy the break, get ready for a new life, but focus on trying to learn something new every day. That way the knowledge you worked so hard for doesn't get lost from a lack of practice, and instead grows, and that in turn lets you grow, personally and professionally, and have fun while you're at it. And Brilliant can be your partner on that journey. Brilliant helps you build real knowledge in minutes a day, with fun lessons you can do whenever you have the time. Learn through problem solving and doing, with hands-on interactive content that's fun, immersive, effective, and intuitive. You can try everything Brilliant has to offer for free for a full 30 days. Just visit brilliant.org/IsaacArthur or click on the link in the description. You also get 20% off an annual premium subscription. So that's it for today, and we'll wrap up the month of May with a trip to Ganymede, the largest of the moons of Jupiter, and indeed the largest moon in our solar system, and we'll ask if perhaps humanity might settle this moon. After that, we'll head into June to look at what sort of jobs in space and the space industry there are, both now and in the future. Then we'll return to the Fermi Paradox and continue last week's discussion on the nature of intelligence to ask if our minds themselves may be a ticking time bomb waiting to inevitably ruin us. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show by becoming a member here on YouTube or Patreon, or check out other ways to help at isaacarthur.net. You can also catch all of SFA's episodes early and ad-free on our streaming service Nebula, along with hours of bonus content like machine monitors at go.nebula.tv/isaacarthur. As always, thanks for watching and have a great week.